Hello, and thank you for joining us today at the Charge Virtual Conference on EV Engineering. The topic of this session is testing bidirectional power electronics, and it's brought to you by Chroma. There will be a Q&A session after the presentation, so please submit your questions at any time by clicking the Q&A button on your screen, and a recorded video of the presentation will also be available to view on demand after the session is completed, and you can visit this session's registration page on our site for more details. Joining us to present and discuss the topic today are Trevino, EVSC Partnerships, as our key presenter, alongside Deel, Product Manager of EV Test Solutions at Chroma. However, Dana is unable to join us live today, but can take questions afterwards, either through direct email contact or LinkedIn. In addition to our presenters joining us, we will also be joined by their colleagues Larry Sharp and Kevin Peck, application engineers at Chroma as well. So welcome all.
Thank you for joining and welcome to the 2024 Charged EV Online Virtual Conference. Our topic for today's seminar is testing bidirectional power electronics. At Chroma, we're testing the future of electronics today. I'd like to start out by introducing our Chroma System Solutions presenters for this segment. We have JoeyT Trevino, our Customer Accounts Relationship Person. Joey came to Chroma 2 years ago from Tesla Automotive, where he was a solar and vehicle sales representative. And myself, Deel, Product Manager of EV Test Solutions. I joined Chroma about a year and a half ago from Rivian Automotive, where I was a Hill Test Manager for the battery team. Here at Chroma, we're supporting the paradigm shift to e-mobility, energy storage, battery and cell test labs, and the EVSE market with best-in-class test solutions. Bidirectional electronics spans decades. It has roots as far back as the 19th century with long-distance telegraph lines that used inline bidirectional amplifiers and repeaters. We take this technology for granted now because it's been such a big part of our everyday lives. Even today, bidirectional electronics is a major contributor to the development of sustainable, power-independent, microgrid and smart grid communities. Bidirectional power conversion made significant impacts in solar and wind renewables. They now extend to the EVs we drive and our charging infrastructure. So you can imagine testing bidirectional components can be crucial, not only for consumers, but also for the infrastructure of sustainable communities. In this seminar, we'll explore testing solutions that are not only comprehensive, but also cost-effective. Today, even equipment we use to test our electronic devices can help support sustainable electrical grids and offer measurable returns on our investments. For the topics we'll cover today, we'll give a short overview of bidirectional power electronics history and uses in electric vehicles. We'll also describe what's driving bidirectional power products of today. And we'll show some examples of test system designs for bidirectional components and their basic test structure. We'll also cover some functional test strategies for onboard charger components and how our Chroma software can impact your test development. And then we'll follow up with an explanation of common inefficiencies in traditional lab testing of bidirectional components. And we're also going to define why you should consider regenerative test equipment in your lab, plus give examples of actual case studies for regenerative cost savings. We'll end our segment with showcasing our Chroma line of regenerative test products. Following conclusions, we'll open up the floor for questioning. But before we get started, I'd like to introduce who we are at Chroma. Chroma, founded in 1984, is a publicly traded company with almost $1 billion in annual revenue. Our corporate headquarters is located in Taipei, Taiwan, with international locations in North America, Europe, India, Southeast Asia, Japan, Korea, and China. Chroma ATE has been one of the world's leading suppliers of test and measurement instrumentation, plus automated test systems for a wide variety of companies and applications worldwide. At Chroma, global presence, local support means more than just a slogan. We have sales, service, and application teams around the world to meet all your testing needs. As I mentioned before, bidirectional communications has its roots in the 19th century, but bidirectional electronics began emerging in early to mid-20th century with bidirectional amplifiers and repeaters for wireless and telephone two-way communication. Large-scale integrated circuits, or LSI, began making their way into smart electric motor drives, making industrial applications more efficient. In the 90s, we saw renewable energies increase the need for efficient power conversion to grid-tied utilities. Around the 21st century, regenerative braking in electric and hybrid vehicles required bidirectional power flow to recharge secondary batteries, thus opening the door for EV batteries to be used as additional sources of power for V2X applications. Later that decade, advanced semiconductor technologies like gallium nitride and silicon carbide increased switching speeds and conversion efficiency in a dramatic fashion. All of these advancements set the stage for sustainable microgrid communities to take advantage of multiple distributed power sources for reusable energy. Regardless of where technology takes us next, bidirectional power electronics will be the foundation for future electronic innovation. So what's driving bidirectional products of today? A key technology driver will continue to be further transitioning to self-sustaining energy with nanogrids, microgrids, and smart grids. Helping with this technology transition are electric vehicles, their batteries, charging networks, and second life battery applications. And bidirectional electronic components inside the EVs are key to this transition. Other areas that could drive technology in these products will be wireless power transfer or wireless charging. WPT is already leading to advances in commercial rail, seaport, and highway transportation. As wireless charging becomes more efficient and practical for our public roads, the need for conversion efficiency for optimum magnetic coupling will carry new solutions forward. In addition, further advances in semiconductor technology will lead to greater power conversion efficiency, size and mass reductions, thermal hotspot reductions, and AI control developments. As these electronic solutions get more and more sophisticated and complex, however, the need to validate these products throughout their life cycle is now more critical than ever before. Chroma has a wide variety of test solutions for these components that can meet or exceed your best expectations for all phases of your product's lifespan. Bidirectional electronics in electric vehicles help support effective battery management to supply V2X applications. Regenerative braking, DC-to-DC converters, and OBCs for hybrids and battery electric vehicles, for instance, are reliant on this technology to make more efficient use of secondary batteries. All components in the EV now are being squeezed to obtain every ounce of usable energy for reuse either inside or outside the vehicle. In recent years, EV companies have been designing in bidirectional power features specifically to support V2X applications. The testing process for these critical components is also an area where we can reclaim energy that would otherwise be lost to heat using regenerative test equipment. In the latter sections, we'll lay out test system concepts for some bidirectional electronics being implemented in EVs today, and how regenerative test equipment can pay you back on your investments. What's being shown here is not a comprehensive list, and a test system layout will depend on your product needs. A couple of main EV components getting an electronic makeover are onboard chargers and DC-to-DC converters. A traditional method of lab testing a bidirectional DC-to-DC converter, for example, you'd need a couple of power supplies and loads on the input and output sides of your DUT. There are benefits to this type of lab setup initially. It's usually cheaper to set up, and equipment can be redeployed quickly. But labs can get cluttered with distributed equipment, and test and debugging can become more complex because you're controlling and gathering data for 4 individual units or even no data if you're using discrete components like the power resistor shown. Plus, you have to consider additional lab space or lab cooling because heat dissipation from the loads can be excessive. However, as your requirements demand more complexity and efficiency in your test results, you look for ways to rack and stack and automate the process. A better solution to distributed inefficient testing would be to use bidirectional sources and loads combined in a single package and integrate it into a comprehensive system. This not only reduces lab space, it makes testing seamless with integrated device control and data gathering. Plus, the heat generated during testing can be mitigated if you use regenerative test equipment. For an integrated systems approach to testing an OBC, we start with a centralized distribution point for integrating equipment back to the DUT. One direction of test source could come from an AC level 2 charger plugged into the EV inlet port. Chroma bidirectional grid simulators paired with an EVSE emulator is a good choice for this. On the load side of testing this OBC, a Chroma battery simulator can provide the power and characteristics of a battery pack. And with our flexible Chroma test systems, you can also add testing for DC to DC converters in one integrated package. And then to verify dynamic signals, measure power efficiency, you can also integrate external devices like power meters and scopes. Finally, for test control, conducting tests, and generating reports, we integrate industrial PCs along with Chroma's line of quality software. Our professional test software suites have built-in test libraries to cover common or necessary standards testing. This makes test development quick and easy. I'll go over this later in this segment. Just to summarize the last two slides, the side-by-side comparison shows how using bidirectional test equipment can reduce the number of test pieces needed, which reduces clutter and increases safety, and could increase your test output and efficiency with integrated control and real-time data gathering. But what's missing here is how regenerative test equipment can impact your test system and your bottom line. Later in our presentation, Joey will explain why regenerative test equipment is a wise choice for reducing costs and addressing problems with distributed lab equipment. I'd now like to discuss some common test strategies for onboard chargers. Onboard chargers and other power distribution components for EVs are getting more complex every day. Compliance and regulations surrounding these devices are also becoming as complex as the devices themselves. Adding to the complexity are other components being integrated into OBCs for packaging and mass reduction, harness reduction, simplified cooling, software integration, functional zoning, and others. Then if you throw in demands for V2X testing, increased efficiency, power scaling, safety and regulatory, plus standards compliance, testing of these once simple power conversion devices can be a daunting task. So where do you start? If you're still in development, functional tests are a must to ensure your products will meet its intended design and it complies with downstream testing before production. I'll go over some basic functional test plans and how our Chroma software products can help you get a head start on your test development. A sound test strategy starts with a clear understanding of requirements and test objectives. From the requirements, natural language tests can be written. For ease of development, you might consider putting common, repeated tasks into reusable libraries. This could include things like flashing the processor, quick checks for electrical, power up and power down sequences, or even some common standardized functional tests. A typical test procedure could include things like charge and discharge modes, communication, safety and fault testing. For charge mode, input power quality gauges the product's response to input line disturbances and harmonics. Charging efficiency can validate how effective input power is being converted to the output. Voltage and current quality are a measure of the hardware's circuit performance, reliability, and stability. This could include things like range and limit checks, transient response, power factor correction, ripple allowance, and others. Connectivity and communication checks can become substantial given the complexity of our charging standards and compliance for power fed back to the grid. Discharge mode testing will involve much of the same validation as charge mode testing, with additional tests for vehicle-to-grid compliance standards. Finally, rounding off our example test procedure are safety and fault, or diagnostics testing. These two areas help protect consumers and other system components, as well as determining your product's fault management capability. If you had to start from scratch to attack all this, it could take months to plan, develop, and run tests needed for proper test coverage. And if you take into consideration the development effort needed to integrate and control complex test equipment, you could be facing huge amounts of work and rework. Above are just a few of the industry tests for electronic components for standards testing. These tests above are targeted for the Asian market. But keep in mind, there are different tests for other markets as well, each with their own set of required test coverage. Fortunately, Chroma has made developing tests a more simple process with a comprehensive lineup of test software. We have specialized software for industry applications to help solve complex issues of testing. plus specialized user interface panels or soft panels for individual instruments, and a wide selection of automated test software that allows you to develop, manage, run, deploy, and report on your tests. In addition, we have many common instrument drivers for those who want to develop from the ground up or simply integrate into other systems. PowerPro 5, our flagship automation test software, is our most versatile and most popular of our automated software packages. In PowerPro 5, there are over 100 built-in test libraries for common industry tests and standards compliance tests. This allows for quick and easy development of tests that are critical to your design. PowerPro 5 is also multi-threaded and allows for creation of sub-function calls for common tasks that may be repeated often. This helps quicken your test cycles and creates a more realistic test scenario. There is also external support for function calls in DLL or Python format. This is on top of the many external device COM interface options we have in PowerPro 5. With Chroma's professional suite of automation software, you can decisively scale down your time to market and reduce the risk of product failures with repeatability and precision. Next up, Joey will show you how Chroma's regenerative test equipment works and how this can pay you back on your hard-earned asset investment. Joey?
Hi, everyone. My name is Joey Trevino, and I'm our EVSE Accounts Coordinator here at Chroma. Today, we'll be discussing a few things tied to regenerative testing and the future that we see ahead for it. As Dana mentioned, microgrids and regenerative testing go hand to hand to play a role in a society with sustainable energy. In this segment, I'll dive a little deeper on how testing the regenerative way can not only benefit you, but your facility and your microgrid. In my part of the presentation, I will discuss the following. We'll go over common inefficiencies with traditional testing, the regenerative testing approach, the key benefits of regenerative testing, and we'll go through our Chroma line of regenerative instruments. Let's talk about the inefficiencies first. With the traditional way of testing, a typical setup might look like the picture below. Tests pull power from the grid to the facility AC, then to the source, to the DUT, and then finally out to a load. For years, it's been done the same way, but why? I'll explain here why this way of testing is inefficient. Let's start by talking about heat. There can be large amounts of heat being emitted from your loads. Not only will your lab get hot, but you'll be more than likely to have to bring in HVAC units to cool down your lab and your equipment. This will burn through money, planning, precious lab space. Regarding space, you're going to need a lot of it to store your HVAC units to deal with the heat. Also, without bidirectional test equipment, you might also need to double the amount of units you need for testing. This could take up more lab space, which could also lead to extra clutter, and possibly some safety concerns. Now, from your units, you're going to have utility consumption. And depending on your utility company, you will be billed more during the day during certain time windows for drawing power to your facility. This billing structure is called time of use. From this, there's going to be no benefit to your grid. Not only are you emitting extra heat from your loads, but you're using large amounts of air conditioning to cool down the room, which is negatively impacting the grid. You're not really playing a part in your microgrid by pulling more electricity for these tests. And lastly, you're not going to be adding any benefit to your microgrid. In a microgrid community, the whole idea is to give back and support your community. With traditional testing, you're doing the opposite. Now that we've discussed the traditional way of testing, let's talk about testing the regenerative way. So here's how it works. Power is pulled from the utility company to the facility, to your test source, then to your DUT, and then finally out to your test load. From there, instead of wasting the power and dissipating all of it in the form of heat, you're pulling most of it back in for reuse. And this is similar to an electric car's regenerative braking function. And you may be wondering, how do I reuse this energy? Let me explain. The first way would be to send this power back to your facility to use at a different time. You're going to need to make sure your facility is set up for this. You can also send it back to the utility company. Typically, they'll give you some sort of credit on your utility bill each month for this. Lastly, and most efficiently would be to use this energy to power a secondary test. However, let's say you're only doing one test and your facility and utility company are not compatible for feedback energy. In this certain case, we do have optional loads you can use. If you have any questions on that or like more info, you can reach out directly to us. As you can see, taking advantage of lost power is a win-win. So let me highlight the overall benefits of regenerative testing for you. You're going to have less heat emitted in your lab, which will provide for higher savings on your electric bill. There's going to be less space required in your lab, which means for faster setup time and less overall headaches. Less penalties from your utility company's time of use plan, and a greener footprint for your community. Now, the biggest benefit would be the sheer savings you'll uncover when switching over. As I mentioned before, the lack of heat being emitted means more power saved, which is directly correlated to your wallet. Here, I have a study ran by Chroma and through client data. So in this test, we had a 15 kilowatt inverter as the DUT, and we're using our 63800R regenerative load to test it. Over a 1-year period, based on an average kilowatt hour price of 20 cents, which was the average price in California for 2022, with an regenerative energy cycle rate of 89%, you'd save approximately $5,000 a year for a single lab. Now, if you're using this in a factory or production environment around the clock, you can see upwards to about $24,000 worth of savings per year. Now, keep in mind, this is based purely on power consumption from your tests. This is not calculating air conditioning costs that you will need to factor in when cooling down your lab. Regarding air conditioning costs, let's take a look on how much that may cost you as well. Now, let's take a look at that same exact test. With a 15 kilowatt DUT being tested, on average, you're going to be pulling about 4.25 kilowatts per hour, on average, based on your central air conditioning system. For simplicity, let's leave other factors like the amount of people in the room, lights, or other things out of the picture. With 4.25 kilowatt hours, this leads to about 170 used per week and about 8,160 a year based on normal use of a 40-hour work week. If we take that same 20-cent average and multiply it by that, we will find that it will cost you around $1,690.75 a year on average just to operate the single unit. In a production environment, this cost will be much higher most likely. We do have some great data on regenerative testing in a production environment as well. Let's take a look at this study. In 2006, Chroma collaborated with Coolburn on a burn-in test system. Chroma's purpose on this collaboration was to develop a burn-in system that is designed to make testing more efficient and to cut back on the amount of heat their burn-in units were producing. This test, which used an 11 kilowatts DC power supply as the DUT, emitted 10 kilowatts of heat from the resistive load banks as seen above. This was averaged to use around $392 a week in operating costs and $600 a week in changeover costs. With Chroma's design on a burn-in system, instead of emitting 10 kilowatts of heat, this was reduced all the way down to 1.5. This drastically changed operating costs, and operating costs went down to $97 a week with changeover costs going down to $100. Let's take a closer look. Here, I have the system that Chroma designed, as well as the before and after results of the test. As you can see, before Chroma stepped in, Coolburn was using 110 watts of input power and dissipating the same. After Chroma was involved, you can see the input power and dissipated heat was largely reduced from 110 watts all the way down to 25. From this, we saw an astronomical amount of savings for Coolburn, like most of our clients. In 1 year, Coolburn saved $93,340 by switching over to our system. At the end of the day, the cost savings alone can pay for the regenerative unit over time, especially in this setting. Although this test was done in a production environment, you'll still see large benefits on a day-to-day life in a lab. When choosing your equipment, it is crucial to carefully choose the right fit to avoid burning through any money or resources. Time after time, we see clientele purchase the wrong units, learn their lesson, and switch over to something more sustainable. This not only burns through money, but wastes time, as you engineers know, is by far the most important thing. Switching to regenerative test equipment alone could open up your budget for other projects and increase the efficiency on all the current ones you have. As for your engineers, you may use this information as ammo when bringing this up to management or your purchasing team. Now let's jump into our units. We'll take a look at our regenerative product line. In this next portion, we'll take a deep dive into our regenerative battery test systems, sources, loads, and grid simulators. Let's take a look at the battery pack test systems first. Let's start with our Chroma 17020 and 17020E. These regenerative battery testers are great for testing battery packs, energy storage systems, motor drivers, and power control systems. They can test using individual or parallel channels for higher capacity battery packs, if that's what you're testing. If you're in the automotive industry, our cyclers allow you to do drive cycle tests that simulates driving and regenerative braking events on the battery. They have quick response times and smooth current changes between charging and discharging without overshoot. This will protect your battery so you don't have to worry about damaging it. Another great feature would be our dynamic driving profile simulation, which simulates real conditions on the battery pack via the condition simulator. Now, if you like that but need higher power, we have our 17040 and 17040E right here. The 17040E supplies massive amounts of potential. It can be paralleled up to 1.2 megawatts at 4,800 amps. Just like the 17020, they're super versatile with pack testing, and there's actually a specific battery simulation mode for testing battery packs. Regarding your test system, we at Chroma actually have specific software to help with your applications. This can be a great solution, especially since there's no licensing fees. At Chroma, we have a team of skilled engineers who can help rig up your test systems for your tests by supplying drivers and support. You can most definitely program software yourself, but you'll have to see if it's worth it first. In most cases, you'll have to find someone to code, wait for it to be done, which could take up to 6 months, and troubleshoot it. We all know how annoying that can be. Instead of taking time, resources, and manpower by doing this in-house, our team of experts can help you with the heavy work so you can focus on your actual job, making things happen, and creating something great. At Chroma, our primary focus is staying with you the full way through setup so we can both conquer your applications and progress further together. Let's talk about our benchtop instruments. Right here, I have the 62000D. This is our bidirectional DC power supply, which also has a regenerative load option. The D series is great, quite popular for a few reasons. A few different features include solar array simulator, which allows for testing solar inverters and simulating different lighting conditions. Awesome for simulating batteries and EVSE equipment with its bidirectional feature. And with the bidirectional feature, you can use it as a source, a load, or even both at the same time. And they're great for racking because of the super high power density in the 3U package. At Chroma, we are confident to say we are leading the pack in power density. Now, if you're looking for one of these with higher power, we also have more units in 4U that can go up to 45 kilowatts of power. Next up, we have our regenerative AC and DC loads, the 63800R and the 63700. If you're looking for a standalone regenerative load that is not bidirectional, these are your go-to. These units can be used single or three-phase and are great for a ton of different testing situations. These are best used for EVSE, OBC, off-grid PV inverters, power electronics, UPS tests. These loads are fully programmable, can come in a power-dense 3U size as well. They come standard with USB and LAN and have an optional GPIB connection. If you're operating in an automotive application, you can also get it equipped with CAN. Last but not least, we have our AC grid simulators. These are ideal for smart grids, PV inverters, and EVSE charger-related tests. Our grid simulators have a super high amount of power, can be paralleled up to 840 kilowatts. We have a high voltage option that can range it up to 1,000 volts as well. A great amount of our clientele uses these to test AC line disturbances because our soft panel software has a built-in test library, specifically with all kinds of line disturbance and compliance tests. These units are fully regenerative and can be used bidirectionally with our AC load option. And if you're looking for a high density version of the 61800 to rack or use at the bench, they also come in 3U. It's 4-quadrant and has user selectable single phase or 3-phase outputs. This concludes today's seminar. We want to thank all of you for the opportunity for us to share our experience, tips of the trade, as well as showcasing our great line of Chroma products. As you can tell, testing bidirectional power electronics can be no simple task. However, whatever your testing needs, Chroma has the right solution to fit your application. So let's solve your problems together. Thank you. So we can start taking questions now. Please forgive us if we're not able to answer your questions during the seminar. However, if you'd like to leave your contact information with us, we'll follow up with your questions after the seminar. You may also find our info up here on the slide if you want to reach out via email, call us, or reach out on LinkedIn. Once again, thank you very much for attending.
Thank you for the presentation. Now we will begin the Q&A session. So if you have any questions, go ahead and click the Q&A button on your screen to submit them. I see that we have a few that have come in. If you could begin by reading the question aloud, that would be great.
Hello, everyone. It looks like we do have a few questions coming in. The first one, it says, what is needed in my facility to utilize regenerative feedback? There's nothing special required. The only requirement is that the power from your grid or from your utility power has to be able to handle the full power being fed back from our devices that are regenerative. So that's the only main condition. We take care of our unit will synchronize with the grid. It will work using a actual phase lock loop and a constant current generator type of output to allow it to put power back on the grid. So all we need is a good solid connection and a voltage supplied from your grid.
All right, so for the next question, we have, can you use regenerative test equipment to power one another? So the regenerative equipment can be used to power each other, but they both need to be connected to the grid. So you can't just have one unit directly connected to the other and the regenerative power will power the unit. They both have to be connected to the grid, receiving input power from the grid, but the regenerative power will go back and redistribute through the panel, facility, anything to the other unit. So it does power each other in that way.
Sorry about that. So the next one asks about if our regenerative equipment efficiency is the same when it's in regenerative mode as a source and as a load. It's only regenerative when it's actually a load, when it's pulling power from the device under test, putting it back to the grid. When it's operating as a source, it still is the same efficiency because it's only dissipating a small percentage of the input power from the grid before it sends it off to the device under test. So that efficiency is the same in both directions, whether it's regenerative or whether it's acting as a source. In most of our units, it's in the high 80%, some of them as high as 90 to 93%. So depending on the device, we could give you the exact numbers, but yes, it'll only dissipate approximately 10%, or in some cases even less, of the power when it's operating up at the higher power level of the rating of the unit.
And so next question we have, do you need a heat sink to capture or store heat and reuse? So the answer is no. The units will automatically regenerate the power back to the grid. So the units, when they receive the power, they'll automatically translate them from either AC to DC, back to AC, or from DC to AC, and it will go straight to the grid, and it will directly redistribute to any present loads that may require the power.
So there's another question. Are you able to swap out power supplies in the battery test system with different models of voltage and current? Yes, we can. We do have various different voltage and current and power rated modules that go into our battery test systems, and therefore you can change those out. You could even mix them within it if you're testing both low voltage and higher voltage, lower power and higher power versions of batteries within our test systems. So yes, you definitely can do that. The power supplies, battery test systems, we have a large number of different versions. And if you need more information on that, let us know, and we'll be happy to send you some documentation on the various types of supplies and loads that we have available for our battery test systems.
So the next question is, what's the minimum input voltage required to operate the unit? So our units differ per unit, but generally they operate at either three-phase 120, 208, or three-phase 480. Generally at three-phase 208, some of the units derate sometimes, so that could either be 2/3 power, 80% power. It depends on the unit. So it's good to check with us before to validate that the power is good.
Good question. It asks about the power dissipation during high load testing. Because the units are regenerative, they actually produce a very small amount of the total power related to heat. So the heat dissipated is normally just handled through a air-cooled heat sink arrangement. So for that reason, and the fact that it's very efficient, and the fact that it's regenerative, it's a minimal amount of heat that is dissipated by our product.
So the next question we have here is, will Chroma equipment be compatible with moving from 400 to 800 volts?
So the units can regenerate their full range, their full input range. So if the units are rated for that specific voltage, then they can regenerate that, no problem. They can translate, transform, and convert it to the right power.
Another question, kindly comment on the noise generated by pack testing rack. I assume when you're talking about noise generated, I mean, when you're talking about batteries in general and battery testing, a battery is a very low noise device. If you're doing any kind of dynamic testing or cycling, during the transition time, there may be some response. As far as the actual noise generated by the pack, if you're looking for a value or a spec limit or something of that nature, feel free to reach out to us, send us an email. All of our contact information is the end. We'll be able to talk more specifically if you give us more details on what type of noise you're referring to and the noise generated by the pack. If you're referring to regenerative noise, when we're going back to the grid, we do meet the requirements for the minimal harmonic distortion, and we do meet the requirements for anti-islanding and several of the other things that are in several standards that talk about the quality of the power that we put back on the grid. So you just need a little more information, but feel free to reach out to us. We'll happily answer your question in more detail if needed.
Another question, any product specifically targeted at 48-volt automotive battery buses? So off the top of my head, we do have two. There's the 62,000D, there's a 100-volt version, which is right in that range. And we also have a 60-volt channel tester for our 1720 system. So you can also use that for multiple pack tests or battery testing. But reach out and we can properly align your needs with any of our products.
We have another question here. What is the approximate lead time? Let me see.
Yeah,
so lead time varies unit to unit. We have different types of different specs per unit. If you want more info on this, you can shoot us an email. Our info is below, or you can send an inquiry on the website, and we'll get back to you ASAP. We can set up a call and get that info to you.
So it looks like the question related to noise was related to decibels for audio and fan noise. It does vary from one piece of equipment to another, varies greatly depending on the power range. Our typical dB is down in about 60 dB range. We do have some units that at full maximum power, at the higher power ranges, when we're talking about multiple units, they can get up close to 80 dB. But most of our units are in the 60 dB range, if that helps. Did that go through?
We have a question about sharing the presentation, and I posted a link in the chat box to download the slides. I will post it again right now. so everyone can download the slides before the end. Also, we had another question about will this recording be available? And yes, it will be. I'll also post a link in the chat box to the session registration page where you can watch the recording in a few minutes after it's processed and uploaded. So, do you guys see any more questions that still need to be addressed? I think you got to most of them.
Yeah, I think we addressed all the questions.
Great. That's perfect because we're running out of time, so we'll wrap up there. Thanks so much for everyone for attending, and thank you for the presentation and all the great questions. This was a good conversation. As I stated a few times now, you can watch the recording online, and you can also feel free to share the link with your colleagues who weren't available to attend live today. So once again, I just want to say thanks everyone for taking the time to attend, and I hope everyone found it valuable. Thanks, guys.
Thank you.
Thank you.